Hi, welcome to this video. In this video, we are going to look at static classes. Now, so far, we have already done some coding with static classes. Some of you have created helper functions, um, and you've been able to make your code a little bit easier to read and work with. What we are really interested in is what we call good practice, good coding practice. It's not just a question here. We're not just simply interested in splitting up your code into useful functions. What we're going to look at is why we do it, why it helps you actually works with your code. Some of the lecture notes talk about cognitive load theory. And cognitive load theory, I'll just write the name down so you can see. Cognitive load theory is essentially a concept about how to manage increasing complexity. What you notice is that when you're studying a subject, right, if this was a complexity vertical and this was, say, period of study, the complexity of your learning may stay down there, but with programming, it tends to go up, level out, go up, level out. These increases in complexity when you're introduced to new concepts can make it really difficult, because if you don't master and get confident with these lower levels, then shifting up to the more abstract and higher level types of concepts puts a lot of pressure on you. It creates a cognitive load, it creates pressure, it makes you feel more confused, it makes you feel more pressured. So one of the fundamental issues that I am interested in doing is helping you understand how you manage complexity. There's more to it than just simply you've got a complex program. There's also, as I've said at the beginning, good practice involved here. And what we're going to look at is a couple of simple examples that you've already partially worked with, but we're going to start off with perhaps the most important central concept. So give me a minute or two just to explain the central concept, and then I will use that concept in the code that I write and encourage you to do the same in the way that you code. So what is the concept? What's the fundamental concept? It's probably, I would characterize it with this diagram. And I'll just write it out. Give me a moment. There are two levels here. One is the concept, right? So what do we mean by the concept? And what do we mean by mechanism? Well, let's spell this out a bit so I can explain. Concept is really what you're trying to do. If you were to write pseudocode or try to paraphrase what your code is doing, you would be describing the concept of what your code is doing. Okay. But when you come to writing Java, you actually have to build mechanisms of how to do this thing up here. Now, what we notice, a very common experience for teaching introductory material, and actually all levels of programming have this, but later students hopefully are taught with this type of concept. I'm trying to find another. That's no good. The concept that we're constantly finding is that students get fixated on the mechanism, and that's all their coding experience is. And so in a very short space of time, they just get overwhelmed with the lines of code. A very typical example is you have a while loop or some kind of loop. Inside it, you have nested if statements, and it can just get more and more complicated, longer. These are all mechanisms. These are all how you implement concepts, right? So the mechanism is all about how you implement your code. Now, we're studying in Java. The concept here, the idea here for you to bear in mind is that once you are clear about what the concept is your code is trying to do in pseudocode, or I'll show you a system of how to use comments to help you do this, helps you establish what your code should do, especially all the bits and pieces involved. Then translating it into the relevant mechanisms gets really interesting, because what you try to avoid doing is simply taking your concept, and this is what everyone is, not everybody, lots of people do. They just take their concept and they literally code it. So they have a while statement, an if statement, and then they'll have another if statement here. Then they might have an else condition. Then maybe another loop here. It's huge. It's a huge chunk of code. This type of programming is called procedural programming. And one of the fundamental issues is that although at this stage with these simple problems we're setting you, you can code the mechanisms to make these concepts work, what you're trying to do, it actually doesn't scale up. Procedural program has real limits in terms of scaling up. So we need to have an approach to how we code, which will allow us to scale up, which will be a good practice, a kind of repeatable method and approach, and helps you manage complexity. So one simple example is the use of the quite limited notion of static functions and classes. Now, the most obvious example we've been using for static classes and functions is the print statements and get in statements. So what we're going to do now is we're just going to code, and in the process of this bit of code I'm going to illustrate this. We're going to also discuss why it's limited, but let's get some code done. So first of all, in your case, you may already have it. I've got a folder or package called my files. Let's just call this, let's rename this so it sort of corresponds to the lecture. So this is week 4. Bear with me a second. This is static class example, right? I'll call it that just so, oh yeah, the problem is I use gaps, so I can't use gaps. So get rid of the gaps. Bear with me a second. Static class example. Gaps, spaces are very unpopular. Right, okay. So here I'm going to keep my static class example. So I've got my program here. And let's take an example of something we want to do. But before we do, let's break down what we do with our user interface. Okay, let's think conceptually what we do with our interface. We normally, if you think about it, we get input, we process that input, and we typically output some result. Okay, what we're going to do is we're going to make this whole structure simpler to do. Now what we've done so far is I've encouraged you to create, not all of you have done it, a helper function, but I'm going to call this console functions. I'm going to give you a particular example and we're going to discuss this very specifically and how this works. Right, in console functions, I'm going to create a simple print method. Okay, part of the exercise is, if you haven't done this, now I just copied and pasted that straight from the sheet. It's a print statement, you pass it a string and it uses system out print line. Why do we do this? Why do we actually bother to do this type of stuff? What's the point? Why don't you just use system out print line every? Okay, this introduces a very simple example of how to get output. If you are doing output to a console and you want to just send it some string, you can literally write this. Now, one issue I have here is that I need to import my static class into this particular folder. That's why it's underlined it, cannot resolve it, etc, etc. You'll find you can't do it. So what we need to do is just do an import, and we use the static keyword. Thank you very much. I can't remember who showed me when we had this in a lecture. The name of the basic package is static class example, and what we're going to do is call it, there we go, there it is, console functions. That's the static class, and I'm going to use an asterisk at the end, which means I want all the functions inside console function available to me. You notice it's not complaining anymore. I can just run it. Now here's a point. If I want to just run this one, right click, run main. Right, let's have a quick look. This is a simple example, but you'll see how this scales up very, very quickly. We are using, just at the bottom it said, there we go, and it says what it says. Now, this is me wanting to output something, right, by using this print statement. What's the difference between using that and system out print line? Because the truth is here, print is a concept. It's closer to a concept of what I want to do. System out print line is the mechanism used, or one of the many mechanisms you use to output to a console. So when I talked about this distinction of a concept versus a mechanism, what we're trying to do to get good code is that we're always trying to create wrapper functions, and I'll explain that in a minute, which capture the purpose of a concept. The mechanism is hidden inside this wrapper function. So what do we mean by wrapper functions? And I'm going to write this out, because this is a concept that you will come back to again and again and again. This massively improves the quality of your code if you get your thinking in the right way. So it's not just a question of creating a print statement. It's a concept. Print is a concept which wraps a mechanism. It hides how it does it and simply says, that's what I want to do. That instantly improves the quality of what you do. Now, print may not be the best. You might say that actually isn't that clear. Why don't we say output to console? That's much, much more explicit. And I've used what's it called, refactoring, to change the name of it. So I say output to console. When you look at it here, it's actually even clearer, output to console, right? So print might be a useful word for you. So when you're deciding, this is the second decision, to write good wrapper functions, you always name them so they're conceptually clear, right? The concept of them is absolutely clear. The concept here. So if you look at it, output to console says what it does. Okay, so that's the first observation. Is absolutely critical. For those of you who already started creating helper functions and doing this type of thing, ask yourself, is the name of the function conceptually clear? Is it clear what it is trying to do? Because it indicates through the name of the function, right, what it's trying to do. So that makes your code instantly readable. Okay, so a nice and simple output to console. So that's a very, very simple way we have hidden. We just said we want to output to console. There's the data. It couldn't be simpler than that. Now we are going to extend that concept. So part of the tasks and activities I want you to do is fully define a console functions type class, which has lots of static in them. We're going to discuss what the shortcomings of it is. But one of the issues here is that when you have complex programs, having simple wrapper functions, right? Having simple wrapper functions means that you are straight away simplifying the complexity of building a program. It is like a jigsaw puzzle. Keep that thought in mind. Right, let's take another example. Example, if you haven't done this yet, part of the sheet exercise will be to expand this and practice this and make sure you have your own version of this. So another simple example was gate grabbing input. So again, I'm just going to grab this straight from the sheet. There are a couple of observations to be made in here, the underline. And so I want to also introduce a second concept when we're looking at good practice. First of all, what does this one do? This is a get double. It returns a double. That's what that word there. It passes it as string. It creates a scanner object. At the moment, it's not happy with it. It prints. Actually, we don't have a print anymore. So actually what we want to do is replace that with output to console. And it returns the next double. Now, we've had several different discussions I've had with several students about this. Should you put the scanner inside each of these functions? Well, this is again a question of complexity. From your point of view, we need to give you some guidance and some kind of concept, but the subjective element will come to. My instance statement is yes. Why? Well, first of all, let's just fix this problem, right? Let's get the import statement set out. It normally something here. You're going to give me my input statement. import, no, you're not. There we go, it's import. So let's go and grab an import. Let's go and write it manually. Not being very helpful sometimes. Import Java util dot scanner. There we go. Dot. I think that's what I need to do. I'll remember in a moment. No, I just simply need to do right. Okay, and that should do me a trick. There we go. It now recognizes it. Now we have two schools of thought about complexity. Let's use this and let's discuss this. I want from my user to get some input. Let's put our output statement out of sight. Now, if some of you are looking at this and thinking this is really elementary, we know all this, pay attention, because actually we're going to just store a value in there and we're going to run our get double. And we're going to say prompt, let's have a double. Right, I can make it whatever I want. Right, semicolon at the end. Now, in my main program, I don't have any reference to a scanner object. What's the advantage of that versus creating a scanner object here and passing it in as a second parameter? Well, the ideal concept in this type of program is that you wrap every relevant piece of component within the function that you are doing. Get double makes sense to give it a string. It makes sense to have a scanner input. Now, you might say, oh, hang on though, I'm creating more of an overhead. Well, it's a little bit more complicated than just creating an overhead. One thing that we haven't introduced is this concept of scope. So let's just introduce this very briefly and explain it in relation. If you have some function, there's your parameter, there's your squiggly bracket, there's your end squiggly bracket. This body of this function is called the scope of that function. And it has what we call local scope. That means if you create an object inside a function, when it hits the end bracket, its scope has disappeared. It's now irrelevant. And Java has a mechanism of clearing up objects. You can do this manually at the end of the function, but you'll find this type of practice is very common for web systems. Very, very heavily built web systems. It's one version of it. What it does is, by creating the relevant components I need inside my function, I call my function when I'm using it, creates the object, does the job, then it gets to the end of the scope of that function and deletes the object. The internal mechanisms of the environment and server will clean up your object. So you won't create a huge long-standing overhead. What you try to avoid is actually passing in components to it as much as possible. Now this type of programming, this type of concept has come about through the growth of the internet. If you think about a site like Amazon, when you make a call to the server on Amazon, you pass a query, you don't want your server code having created a bunch of objects and just waiting to be used. If you put this outside of the get double inside your program and you have it up here built and ready to use, you're wasting resource. So if you popped it in here, right, think about this, etc., and you popped it in there and you didn't use it until you came to a very specific get double function, it's a waste of resource. So what we have is a we have two different schools of thought. This is the strictest way to only use a component when you need it. Now, there is also, when it's a small scale program, you could put it here and pass it to the double. But the issue then becomes that the signature for the get double always needs you to have a scanner, right? Look at that name there and look at the way we're using it. Oops, that's the wrong button. All that get double is saying that's the prompt that's going to go to whatever user interface I have. Now, there is a second school of thought of why you do everything inside these particular wrapper functions. The second school of thought is this. If I have a get double, and let's say I'm writing on a web page, I'm not using scanner objects anymore. So by having a scanner object available to me, that's only one way I can get input, and it's related to either files. Let's get my screen up, right? So the scanner is related to getting console data. It's also related to files. What happens if you're not getting data from those sources? You clearly don't need a console. So this double would become less, this function would become less usable in a different environment. The advantage of hiding the actual components you need within it is that that console functions becomes the place where you control the environment, the user interface you're interacting with. You don't assume it in your program. You don't need to know. Here is the best place to have it. So if that argument makes any sense to you, this is a good practice. At this stage, it makes no huge overhead having it there. You very briefly create the object, grab the input, you exit the scope, the object is cleared up. Compared to you create your scanner and it hangs about. It's used here, it's still hanging about, it's no longer needed through these lines of code, perhaps a loop you might have in there and all that. Still being used, still using user resource every time you use the new keyword. And then it just hangs about. Now that is a bigger overhead. Smaller overhead is quick creation, use, and it clears up going out of scope. Right, so that is another good practice. Why I would encourage you to do it. Now, I'm going to come to the end of this particular video, what I'm going to give you is a bunch of simple exercises. I'd like you to, for the end of this exercise, to write your own methods to expand this console in this particular way. Create console functions. Now, these console functions are only to be used in your main. So that is the task that I would suggest you do.